I'd like to mention the rotation speed of stars around the center of galaxies. So in this case, is the horizontal line is the distance from the center of the galaxies. Center of the galaxy. And the vertical line is the orbital speed, v. The unit is a kilometer per second. And the horizontal line is 1,000 light years. The orbital speed is increasing with the increase in the distance, like this one. And it becomes nearly the constant. Some fluctuation is happening, but nearly the constant. And the sun is located around 30,000 light years from the center of the galaxy. And the orbital speed is at 250 kilometer per second. So this is the orbital speed of stars around the center of the galaxies. Orbital speed of stars in the galaxy is very, very different from the orbital speed of planet in the solar system. Orbital speed of a planet. So if you draw the orbital speed of the planet, v times r is the distance from the sun. The sun is here and the planet is rotating. Then the orbital speed of the planet is actually decreasing with increase in the distance from the suns. So we have a very different orbital speed curves in the case of the galaxies and in case of the solar systems. So in the case of the planet, actually the single object is dominant in the field. Sun is really big one. Sun is the dominant. Gravity source of the gravity. But in the case of the galaxies, actually supermassive black hole is located at the centers. If the supermassive black hole is very, very heavy compared with other stars, we expect the same orbital speed with our solar system. But in the case of the galaxies, very different orbital speed curves we obtain. So this means a supermassive black hole is not massive enough to determine the gravitational field of the galaxies. Okay, so we should remember that this difference of the orbital speed of stars, orbital speed of planet. Then we'd like to find out the actually mass of the galaxies. Then we use this rotational speed of stars to calculate the mass of the galaxies within the orbit of stars. Then we'd like to consider some circular motions of the stars. Actually, this is sun we could consider. Sun is rotated around the center of the galaxies. Sun is making a circular motions. So sun is making circular motions. Rotating, yeah, moving around. In order to find the mass, we use Newton's second laws. So, do you remember the Newton's second law? This is mass over star times acceleration equal F force acting on this object. So mass of the object, so in this case the mass of the sun, the acceleration of the suns, and the force acting on the suns. Then in the case of the circular motions, these kind of circular motion, this type of the circular motion, accelerations is easily defined. In the case of the circular motion with the radius of the r, acceleration is given by speed, square of the speed over the r, distance from the centers. Okay, and for the F, force acting on this object, we use a universal law of gravitation. This is one of the greatest discoveries by the Isaac Newton. Is proportional to the product of the two mass. Mass of the m is a lower case of the m is the mass of the planet, mass of the suns, and the capital M is correspond to the mass inside of the orbit. This is the capital M. So we don't have to take into account the stars outside of the orbit of the suns. Okay, this is not included. So mass is just only the mass is inside of this orbit, and over the universal law of gravitation, inverse square r squares, and the gravitational constant of the g. Okay. Then the universal law of the gravitation. Find out that this g is given by 6.67 times 10 to minus 11 meter over kilogram second squares. So you can use this A and F into the Newton's second laws. So we are going to substitute these equations. M b square over r equal g m over r squares. The lower case of them appears in the both sides. M is cancelled out. Then from these equations, what is the unknown quantities? Unknown quantities. We know the orbital speed of the suns, the distance from the center of the galaxy. We know the g is constant. These are known quantities. So unknown quantities actually is m. M is a mass inside of the orbit of the suns. So this m. So we could write and m equal capital M equal v squares over g times r. Okay. So this means this mass is increases with the distance from the center of the galaxies. So if the r is increasing, m is increasing, then v is constant. So in the case of the galaxies, actually the v is constant. So the distance from the centers from the galaxy is increasing, the mass is increasing. Okay. Then we'd like to use this equation to determine the masses inside of the orbit of the suns. So you can substitute b equal 250 kilometer per second squares, and the g is 6.67 times 10 to minus 11 meter per kilogram second squares times r is distance from the center of the galaxy, 30,000 light year. Then you could convert from the light year to the meters or kilometer to the meters. then you could find out the masses of the object inside of the orbit of the suns. Then you will get 2.5 times 10 to 41 kilogram. So we could convert from the kilogram to use the mass of the suns. This becomes 1.3 times 10 to 11th solar mass. The mass of the sun. So we discovered the galaxy, big circles, and then consider the orbit of the suns. The inside of this region, 1.3 times 10 to 11 solar mass.